Hello, I am Paul Charles, the CEO and President of American Battery Factory. We are standing up a nationwide network of decentralized, clean and green, modular and safe lithium iron phosphate cell gigafactories. Each ABF cell factory provides 300 and up to 1,000 new high-paying jobs. The question today is, how should the United States invest in the American battery ecosystem? The short answer is strategically, as this is a matter of national security. We believe all individuals, neighborhoods, utilities, states, and sovereign entities should have the ability and freedom to create, store, and deploy their own energy through battery storage. The most important element in the battery supply chain ecosystem is to have customers, which means supporting cell manufacturers in America that produce safe cells without conflict materials in ESG-centric environments while prioritizing U.S. raw material suppliers. The U.S. should support cell production, which uses lithium iron phosphate chemistry, or simply LFP, not just because it's an American invention, but because it's safe, mature, low cost, has wonderful longevity, can be 100% charged, doesn't contain nickel or cobalt, which is a near conflict material primarily provided by child slavery. LFP cells are ideal for use in multiple markets, including the following three. First, electrification of a wide range of transportation modes, such as trucks, buses, and agriculture vehicles. Number two, energy storage. And number three, U.S. military and government applications. There is no volume production of LFP cells in America today. U.S.-made cells are absolutely needed now in massive volumes and will continue to be in demand for many years to come, especially as the chemistry is enhanced with U.S. innovation. American capital markets should embrace U.S. cell manufacturing. Also, the U.S. government should provide loan guarantees and grants in a rapid processing mode to support the CapEx heavy, fully automated robotic factories. Just to give you an idea of cost, American Battery Factory's modular gigawatt plant start at about $500 million and grow to about $1.9 billion or more. With a national network of decentralized factories, government financial support would go a long way in scaling American cell production capacity and allow U.S. companies to compete with Europe and Asia, where vast amounts of government capital are currently available. The U.S. is about a decade behind Europe and double that of Asia in creating a battery ecosystem. The U.S. can absolutely leapfrog ahead to a position of global leadership if we take a distinctly American cooperative approach to this challenge. We're actively looking to form partnerships with the U.S. government, laboratories, and R&D centers, along with those both upstream and downstream American suppliers of battery materials and services. Please join us.
Hi, my name is Dr. Deanna Ahmed. I lead strategy and government relations at One. We are an energy storage company headquartered in Novi, Michigan, with 100 employees, and we've raised $95 million to date. We are taking our first product, Aries, into production end of this year, and we have 25 gigawatt hours of book business over the next 5 years. So I'm here to talk today about who One is at its core. So One is founded on the idea that range anxiety is the singular barrier to adoption for electric vehicles in today's market. So we have set out to double electric vehicle range as a mechanism to facilitate the paradigm shift that an EV can be your only battery. Our ability to increase range is through our novel architecture, which pairs two battery chemistries to accommodate both the daily driving needs as well as the extended driving needs that consumers can find themselves engaging in on road trips. So Gemini 1 was our prototype of our Gemini architecture, and in January we demonstrated 752 miles of range on a single charge. What we are also working to do is to leverage safer and more abundant materials in our chemistries. So in doing so, we are leveraging 95% more sustainable chemistry, more sustainable minerals in our Gemini architecture, where a leading consumer EV pack right now is leveraging close to around 50% of more sustainable materials. So in using less lithium, no nickel and cobalt, and less graphite, we're able to also accommodate that vision that electric vehicles can one day dominate the transportation market. So in looking at range in miles, in both considering EPA rated range as well as real world range. Both Aries and Gemini are market leading products. Aries represents a lithium iron phosphate structural battery that is going to be entering into production end of this year. And Gemini is that dual architecture. Both of these are nickel and cobalt free. Our goal is to increase our manufacturing capacity, include the standing up of a gigafactory. We're right now engaged in our site selection study, and our vision is to be able to be producing at scale in the next 5 years. And that is going to yield over 2,000 manufacturing jobs, high-paying manufacturing jobs, and the company itself, in terms of its engineering infrastructure, is going to double in size this year. We believe that this will be a $2 billion CapEx investment, and it will grow from there, from start of production up to full capacity within several years, and continue to scale as we work to expand our market. So what One is doing is really working to become a US battery or energy storage company that is going to support the growth of this market in the US. And we believe that we can do so with more abundant, safer materials and leverage a North American supply chain. I think in terms of funding opportunities, we are very appreciative of the Department of Energy as well as the federal government's vision to allocate funding to companies like ours. And we believe that as custodians of opportunities like that, we can help to further incubate the energy storage ecosystem and innovations in the United States that brings the United States back as technology leaders in this space. So thank you for your time, and we appreciate your consideration.
Hi, this is Shailesh Upreti, founder and chairman of C4V and AM3NY. And today I'm very excited to share how we are driving the growth of lithium-ion battery ecosystem in North America. A quick glance to our journey so far, from our birth to the start of our first gigafactory going live this summer. Our first commercially available technology is a cobalt and nickel-free, high-safety lithium-ion cell built with a solid domestic supply chain. Our cathode, anode, electrolyte, separator, and are all manufactured in the US. Our vision is supported by 200 plus raw material and equipment suppliers today. We have raised good amount of capital to support our vision. At AM3NY, we have also secured large cell supply contracts. A strong R&D and manufacturing team has taken in charge to make it happen right here in America. A solid domestic platform not only includes an advanced R&D activity, but also a full smart manufacturing solution to scale the manufacturing up and drive costs down. We are aiming to grow to 38 gigawatt hour as the first gigafactory start ramping up to its nameplate capacity of 1.8 gigawatt hour this summer. As we build a cost-effective domestic solution, we strongly believe market buys what is available and not the best. We continuously innovating cobalt and nickel-free solution to support the market needs, including cobalt and nickel-free solid-state solution. Here is the quick demo of our system-level solution with our exciting BMLMP technology.
We are C4V, innovating molecules to machines to establish a lithium-ion battery technology ecosystem. Today, we are introducing Lyten, a unique cell technology platform. Lyten brings to you a cobalt and nickel-free lithium-ion battery cell technology, providing 40 to 50% higher energy and 5 times more power density than LFP. Lyten is the first ever tabless prismatic design delivering extra fast charge benefits. With cell-embedded cooling loops, Lyten eliminates the need for a complicated thermal management system. The low-carbon and toxic footprint makes Lyten one of the greenest possible battery technologies. Built with a robust domestic supply chain, the profiled architecture makes Lyten one of the best designs for a solid structural stability of a battery pack. Lyten brings freedom from modules to deliver an industry-leading cell-to-chassis and cell-to-pack performance, exceeding majority of the packs available in the market, irrespective of the chemistry. Lyten also comes with an inherent exceptional safety owing to C4V's oxygen-deficient BMLMP chemistry. C4V committed to deliver safety and performance. With Lyten, we are charging ahead.
Feel free to reach out to us. We will be happy to provide you a true domestic solution for your energy storage needs.
My name is Nathan Millicum. I'm the CEO of Electric Power Systems. We currently provide energy storage systems. We provide modules and then charging services and infrastructure focused on the aerospace industry. So EP Systems is a category leader in providing electric propulsion systems focused specifically on battery modules and integrated pack designs. We are going after a $3 trillion marketplace, and we are currently backed by some of the most reputable and credible investors in the world, such as Boeing, Safran. We also have one of the largest automotive manufacturers. EP Systems is looking at a large-scale manufacturing site in the United States. Specifically, we want to manufacture modules, packs, and then take cell manufacturing in-house. Our current cell manufacturing supply chain is in Asia, and we have a strong need to grow that supply chain and build it domestically to serve both our domestic and European customers. Packs typically last on an aircraft 1 to 2 years, and if we can't replenish those packs that are flying, then the fleet is grounded. So we have to look at battery manufacturing almost like a refinery. We need those resources domestically to be able to continually support our industry. Some of the unique technologies that we have are containment systems that make energy storage safe for aviation, as well as controls and power management solutions that make it low cost and efficient to travel by air. Challenges to US manufacturing is specifically around workforce training, getting the specialty supply chain over into the United States, and then really scaling to meet the strong demand that we see in aviation. Our business requires a broad skill set. We have need for assemblers, we have need for professional people, we have need for engineers and even PhDs. Primarily to the manufacturing site, we need people who know automation very well, who can run complex machines. These jobs are high paying and very resilient to changing economic conditions. So we've already reached out to a number of stakeholders in the community, including our different municipalities that we operate in, our county and our state legislatures, and then even our federal representatives. We have broad support throughout these different communities to be able to build this within Utah, where we're currently located. It's estimated that aviation will contribute to 15% of all global emissions by 2050. But more importantly, general aviation is the last remaining industry that still uses lead in its products. And that lead is highly toxic, it's traced to cognitive disabilities, and is particularly harmful for children.
Hi, my name's Harold Rust. I'm the CEO of Enovix Corporation. We're a Fremont, California-based battery manufacturer. We're a US-owned company. We've developed an advanced silicon lithium-ion battery that delivers significantly higher energy density than other batteries. We've spent about a decade of R&D getting our technology to this point, and we're commercializing our batteries in 2022. We went public last year and are building a strong track record of delivering cells to customers this year in the consumer markets. We've also received a grant award from the DOE and are working on cells that will be going to the DoD. So that's an exciting development. When we think about the EV space, our first reaction is that it's a challenging place to start as a battery company. It's obviously one where you have to be a massive scale with significant capital requirements, challenging margins to start, and long development cycles to qualify products. It's for that reason that we as a company are initially targeting the consumer electronics space. That said, there's not a huge difference between, building a battery like this for a wearable or potentially something like this for a laptop device. These batteries are in principle very much the same other than their size. And to make larger cells as well that you could put in something like an EV is really not a fundamentally huge technology challenge. There are some challenges, but it's really more a challenge of scaling the company to be large enough to compete in that space. And so, our goal is to get into that space, but we believe that, support from the federal government would allow us to enter it sooner. And so we'd like to see the DOE support technologies and business plans from a diversity of markets, all the way from consumer electronics to EVs, and support, the capital costs, for those companies to be successful and to create a domestic battery market. It's promising that the DOE has acknowledged the need for domestic cell and pack manufacturing support, which is obviously the core of the EV supply chain. When we think about the supply chain in general in the US, we try to go to great lengths to maximize the US content of our cells, and firmly believe the DOE should incentivize US content of that whole supply chain to grow a robust market domestically. Many elements of the US lithium-ion battery supply chain are underdeveloped. They just don't exist. All the way from mineral extraction to refining and to cell and pack manufacturing, even to sales. And we firmly believe the DOE should call for US content requirements to put the entire domestic supply chain on a firm footing. Not just the endpoint of the sale of the EV, it's really about everything along the way. So thank you for the opportunity to talk today, share our point of view. We definitely look forward to working with the Department of Energy to accelerate the development of our domestic supply chain for lithium-ion batteries and to scale as a company to get to the larger EV market as soon as we can.
Lithion Battery is a vertically integrated manufacturer of cells, rechargeable and non-rechargeable battery packs, and modules, serving the industrial, medical, robotic, military defense, and energy end markets. Lithion Battery develops and manufactures highly differentiated lithium iron phosphate cells, modules, and battery packs. Lithion Battery is currently finishing the construction of a new lithium iron phosphate R&D and cylindrical cell manufacturing plant in Henderson, Nevada. The cell facility has a capacity of 60 megawatt hours per year. This cell operation will be producing high-performance LFP cells for the medical, aviation, and military markets. Given the lack of domestic sources of high-quality LFP, Lithion currently sources its LFP from Vietnam and China. The facility will also focus on the development of formulas, qualifying suppliers, and fine-tuning manufacturing processes for a much-anticipated prismatic facility. The advancements made here will greatly reduce the ramp-up time when the new facility opens for production. Beyond our Henderson cell facility, Lithion anticipates a sharp growth in the commercial, industrial transportation, energy storage market. We are exploring to build a 400,000 square foot, 4 gigawatt hour per year cell manufacturing facility. This facility would fall under Area of Interest 6 or 12. Domestic availability for lithium carbonate is limited. North America has not historically been a significant producer due to a lack of developed resources. With an increased global demand, spodumene deposits in Canada and Nevada and brine deposits in Nevada and Mexico, or even synthetic methods, can be explored. Developing North American suppliers of critical materials, components, and infrastructure, including state-of-the-art equipment, will help to address the current supply chain issues. On the supply chain side, the U.S. has strong competencies in material science and chemical engineering, but lacks an experienced cadre of engineers familiar with the synthesis and production of battery materials at the industrial level. Continued and increased financial support for this community is critical to remaining competitive in the lithium-ion battery industry. Lithion is committed to building its LFP cell manufacturing facility in an economically disadvantaged area and achieving the goals of the administration's Justice 40 program.
Hello, my name is James Treavy. I'm the CTO of Forge Nano and excited to share with you what we're doing. Forge Nano uses a nano coating technology to finish materials such as cathodes and anodes, which enable significantly improved battery performance. I'll be speaking to you now about our plans for cell manufacturing, though you will see another video from Forge Nano as part of this session, which focuses on our intent to enable improved raw materials and reduced environmental impact over current state-of-the-art technology. Forge Nano has been working with numerous industry and DoD partners the past decade to develop and build leading cells for a number of niche applications. We now have supply contracts to deliver our cylindrical cells and are planning to build out our production capabilities to meet that demand with our U.S. dominant materials supply chain, which we've already employed to deliver cells for Space Force and are already in space. Our challenges are not a surprise. To execute on our existing and growing number of agreements, we must obtain funding for equipment, materials, and testing, as well as hire and train a complete workforce. We have U.S. and allied partnerships already in place to execute our plan and just need funding to move things forward to be able to deliver our products sustainably. We're already working with local universities and national labs, as well as the state government, to develop our labor force, and our company was actually founded to address environmental issues. We already have a long track record of successful engagements with the DoD and DOE and intend to provide a medium for future workforce training and data sharing to ensure national energy security. We have plans in place to deliver the safest and highest quality cells and have a flexible product adoption model to enable the most timely adoption of these industry-leading batteries. With that, I appreciate your attention and I'm excited to answer any further questions. My name is James Treavy. Please email me if you have anything to follow up about. Thank you.
Hello, I'm Mitch Koffel, the EVP for Business Development at Nanoramic. Nanoramic started in 2009 out of MIT with government funding. We initially focused on ultracapacitors and used this platform to develop our electrode technology. In 2019, we saw the opportunity to transition the technology to batteries. As you can see in the red box, our neocarbonics technology has been very successful in lowering cost, increasing energy density, and delivering faster charging. The core of our technology is the removal of PVDF polymer binders and the toxic NMP solvent. Neocarbonics is a 3D carbon binding structure. It has worked with all cathodes we have tested, including NMC, LFP, LCO, and others. On the anode side, we have developed silicon anodes with more than 50% silicon. You can see an example of our current energy density for NMC with silicon. We are greater than 320 watt-hours per kilogram and 820 watt-hours per liter. Our research shows additional increases of more than 10%. Neocarbonics is an environmentally friendly technology. Since there are no plastic binders or toxic solvents, the recycling will be more efficient. The manufacturing process uses eco-friendly solvents, and the faster drying time uses less energy. Overall, we estimate a 30% reduction in the energy consumption, leading to a lower carbon footprint. The Gigafactory will combine Nanoramic funds with North American customers. We're asking the customers to invest in the factory to secure supply. The more they invest, the more supply they control. We will then request a matching grant from the US government to complete the funding. This amount of funding will allow us to build a 1.5 to 3 gigawatt-hour factory in the US. Our goal is to have a versatile factory with longevity. We are targeting flexibility with different electrode chemistries and various cell types. For certain legacy products, such as those required by the DoD, we will continue to use industry standard PVDF where necessary. To move forward, we must find partners who will invest a minimum of $10 million for their guaranteed production. This could be, again, DoD, other underserved markets, and limited prototyping for EVs. Site selection is focused on brownfield, disadvantaged communities, and stable, low-cost power. We must work with and help establish raw material supply in the US, and we need to secure government funding. Our Nanoramic Gigafactory has supply chain flexibility, which will support US sources. It will be climate friendly and will create a good long-term jobs in local economy. Thank you very much. Please contact me with your interest.
Hello, my name is Gaurav Jain. I'm from Medtronic, the world's largest medical device company. You may be wondering, why am I here at the Lithium Bridge conference? Suffice to say, batteries are critical to meeting world's healthcare needs. And batteries are really the fuel for innovation in medical technology. And that's what I am really here to talk about. And my ask is to make sure that in this Lithium Bridge endeavor to develop North American battery supply chain, medical devices are not forgotten. And the support for medical devices is kept front and center as these developments go forward. So let me share with you a few examples of the types of needs we have and how this can really work out. Here is an example. This is an implanted pacemaker. Medtronic serves about half of world's implantable device needs. We make our own batteries for implantable devices here in Minnesota. So about half of world's implantable batteries are made right here. In this case, this is a tiny battery that goes inside a pacemaker, which is inside the heart, and keeps it beating for over 12 years in most cases. This is technology that we have developed internally, but we rely on a lot of suppliers for the materials and many of the components that go inside the battery. A different example, this is a wearable product. So, imagine a patient with diabetes or a child with type 1 diabetes, where the parents have to do multiple pricks to measure their glucose levels and be worried about, their long-term health. And contrast that with a wearable device that mitigates that concern for the patients and the child. Ventilators, here's a different area, but again, batteries are critical. We don't want, if there is any interruption in power, we don't want the ventilation supply to get interrupted. And hence batteries in most designs are necessary to run the ventilators. You put it all together, what this means is we are really dependent on battery material supply and battery cell supply, battery pack supply. We have strong partners in Asia today, but as we look long term, we'd love to partner with the broader industry and this initiative here to first bring our own expertise to bear in this initiative for long life batteries, for highly reliable batteries, but also help develop suppliers and through strategic partnerships with other industry players and suppliers to make this area healthy for this part of the world, and also be able to serve our patients who are critically dependent again on battery technology for their needs. Thank you.
My name is David Mechanic. I'm the CEO and founder of Anthro Energy. At Anthro Energy, we are utilizing advanced polymer materials to create batteries that are flexible, safe, and high performance. Our vision is to create conformal energy storage to power the next generation of wearables, medical devices, flexible electronics, IoT devices, and more. We are currently in the prototyping phase and are commercializing our technology with support from the Activate Fellowship, funded by the DOE, and the National Security Innovation Capital, funded by the DoD. We're currently shipping prototypes to customers via our demo kit. Anthro Energy's plan to scale up involves contract manufacturing, as our battery fabrication process utilizes the same equipment and steps as conventional battery cells. However, according to our knowledge, there are no large-scale battery manufacturers in the United States who specialize in making lithium polymer pouch cells in sizes appropriate for wearables and consumer electronics. This has forced us to look overseas for manufacturing and scaling partners. At Anthro Energy, we believe that developing domestic manufacturing capability to power our smartphones, medical devices, wearables, and IoT devices is as important as developing manufacturing infrastructure for EV cells. In addition to funding infrastructure for low to medium-sized pouch cells, We also need to invest in battery manufacturing technicians to operate these lines. Small size batteries often require more customization compared to automotive batteries, creating a need for more battery engineers and automation engineers. These batteries are often sold for higher margins compared to EV cells, which opens opportunities to create high-paying jobs within the community. At Anthro Energy, we have a long-term vision of strengthening the domestic LIB supply chain by building out our own pouch cell fabrication line. This will be critical to power our connected devices and further U.S. innovation in power sources for these important applications. Thank you.
Hello, my name is George Little, and I work at Lyten, an advanced materials and EV battery company based in Silicon Valley. We're a 7-year-old company that exited stealth mode late last year. We've raised over $200 million in funding, and we believe we're cracking the code on how to develop commercially viable lithium-sulfur cells. And the way we're doing it is by using a completely new carbon material that we've invented and patented. We call it 3D graphene. Our plans for establishing U.S. manufacturing are ambitious. We're well along in building a pilot production line at our main factory site you see here, and we expect it to be completed and operating sometime this summer. It will have the capacity to produce over 200,000 cells, or roughly 150 megawatt hours per year. Of course, we anticipate this being a stepping stone to building a US-based gigafactory sometime later. So here on the left, you see an electron microscope image of our 3D graphene, which can be thought of like a regular sheet of 2D graphene, but crumpled up, kind of like what you get when you crumple a sheet of paper. As I mentioned, our 3D graphene is a key ingredient for our lithium-sulfur cells, which you see on the right side. We're able to make our cells as either pouch cells, cylindricals, or prismatic cells. One unique aspect of our cell manufacturing is that our supply chain will be entirely North America-based. Our cells don't use nickel, manganese, or cobalt, so we don't need to import nickel from Russia or Indonesia, or cobalt from Congo, or refined materials from China, like you see on the left side of the slide. We just use sulfur, which is readily available in the US, and we use natural gas, which is also readily available in the US, and which is the precursor for making our 3D graphene. As the slide mentions, a third party's research report states that our cell manufacturing carbon footprint will be 60% lower than that of traditional lithium-ion batteries. One challenge we're facing is sourcing lithium metal, so one suggestion we have regarding government help would be to fast-track permitting of new lithium sites here in America. There are several projects under development, like Salton Sea in California and the Thacker Pass project in Nevada. These are just examples, but our main point is we need permitting timeframes that are counted in months, not in years. The critical path length to producing lithium is already long. Shortened permitting would be a huge help to domestic battery producers like Lyten. That's all for now. Before signing off, let me just express Lyten's thanks for this opportunity to provide input to LiBridge, and we hope that it contributes to our collective efforts to build a top-notch battery supply chain right here in America.
Hello, my name is Oliver Harman, and I am Technical Director at Miltec. Miltec UV is a well-established manufacturer of industrial UV curing equipment with global customers in many industries. We're a privately owned small business on the East Coast of the US and have been in business for more than 30 years. For a little over 10 years, we've been developing UV curing technology for the lithium-ion battery industry, trying to bring the typical benefits of UV to this industry. Miltec's patented UV curing technology improves over current manufacturing processes for battery components in a number of ways. Firstly, we seek to remove toxic solvents from the coating process, making lithium-ion battery manufacturing safer for employees and less damaging to the environment. Miltec's technology allows to substantially reduce the energy use and increase manufacturing speed with smaller equipment requiring less floor space and lower initial investments. These features allow for a significant reduction of manufacturing cost. Battery performance is equal or better than the legacy technology, and we focused to reduce the risk of implementation by making the technology compatible with most existing or planned equipment. From our perspective, the US battery industry faces a number of immediate challenges. Today, the US industry and research facilities seem mostly focused on development of the next generation battery technology. However, in order to compete with global manufacturers in the existing and growing market right now, we're lacking the required infrastructure and manufacturing facilities. Making things even more challenging is the limited capacity of US-based and international equipment manufacturers to even support the projected growth. In order for the US industry to gain an advantage in the global market, manufacturing processes and their improvements are key. However, bringing new battery manufacturing processes from the lab to industrial scale requires levels of investment that small and mid-sized companies often don't have. Bridging the gap between research and full-scale production will be vital. The situation for Miltec is such that we are seeing strong commercial interest in our products and technology. Unfortunately, however, much of that interest comes from manufacturers outside of the US. We would strongly prefer to work with US organizations to help those gain a cost and environmental advantage over global competitors. Also, unfortunately, we found it to be easier to demonstrate the use of UV technology and bridge the gap to manufacturing by using partners outside of the US. Our recommendation is for the US to focus on the here and now. Implementing cost-effective and environmentally responsible processes are needed to compete with international manufacturers. We will have to rely on scientists, engineers, and a skilled workforce to accomplish this, so education, particularly focused on the manufacturing aspects for batteries, will be vital. Equipment manufacturers need support to help the US industry grow at the projected rates. And finally, we need independent facilities supporting small and mid-sized companies such as Miltec in our effort to bring safe, cost-effective, and environmentally sustainable technologies to US companies first. Thank you.
Hello, my name is Stefan Pilutek and I'm introducing Buhler Battery Solutions. Buhler is a global process technology company with activities in advanced materials, and here we have battery solutions, as well as consumer foods and grains and food divisions. Buhler as a company has sales of about $3 billion and a workforce of roughly 13,000 people. It's a 100% family-owned company. In North America, our regional headquarters are located in Minneapolis, Minnesota, and we employ roughly 700 staff in North America. We not only have sales offices, but also several service stations, manufacturing sites, and application centers. In the field of battery manufacturing, we offer two distinct solutions. One for precursor and raw materials grinding, including for silicon grinding or LFP grinding. I would like to focus here on our solution for fully continuous electrode slurry mixing, which is a comprehensive solution starting from raw material intake, raw material dosing, and the mixing process itself, where Buhler offers a whole mixing plant. This is a highly productive technology. We have more than 10 years of experience in this. This technology allows a fully continuous production of electrode slurries at an excellent dispersion quality. It's applicable to all electrode formulations, for example, LFP, NMC, NCA, but also solventless or solvent-free formulations. We've already realized lines with more than 2,000 liters per hour productivity, and we've installed more than 50 lines worldwide. Now, we would like to bring this innovative technology also to the United States. A main challenge in this is a certain reluctance of established manufacturers to adopt newer technology. We see that some players rather stay with established and therefore outdated mixing technologies. With our approach, Buhler's workforce requirements include engineers as well as manufacturing staff, both on the mechanical side as well as on the electrical side. And in addition, installation staff for maintenance, and of course, operation. I look forward to a discussion. You can find additional information on Buhler's battery solutions here and reach out to me at stefan.pilotech@buhlergroup.com. Thank you.
Hi, my name is Rudy Berry. I'm the founder and CEO of StatPeel. We are a Swiss-American manufacturer of analytical instruments to monitor airborne contamination in laboratory and production environments. I'm sure you're aware of the toxicity of some of the materials you're working with. Working with harmful material means to make sure you have as little release as possible. Obviously, in a production environment, you have to put all the necessary engineering controls in place. Nevertheless, it's very critical to monitor exposure even in such environments, because you cannot be sure that you have no release. To ensure the health and safety of your employees, you have to conduct aerosol measurement campaigns. Today's instruments cannot tell you the harmful contaminants among all the other background particles. Personal exposure monitoring is a laborious and slow process. People have to wear heavy pumps with large filters, which are then sent to a lab for inspection. To address those issues, we came up with an integrated system. It's called the identifier. There are three components to the identifier system: a filtration slide as a consumable, a wearable badge, and a benchtop reader with a built-in Raman spectrometer and an industrial PC. The system can be operated by any user without any prior training necessary. The system features lightweight badges that can be worn throughout the day to measure personal exposure. The loaded filters are inspected by the reader, and the exposure is calculated right away. This means you get fast results and all the data remains in-house. As said before, the identifier can be operated by any user. but only the health and safety specialist has access to the data. With the rush to build up the huge production capacities needed to transition to electromobility, it is extremely important not to forget about health and safety. I think it would be a worst-case scenario for the industry, by rushing to meet the green and sustainable goals, that the workers involved would pay with their health. If you want to evaluate the capabilities of the identifier, try out our sampling kit at your location. Please take a look at our flyers and videos to learn more about StatPeel, the identifier, and our sampling service. Thank you for your attention.
At Thermo Fisher, with 100,000 colleagues around the world, we are committed to innovation and delivering global thought leadership. Our experts are continually developing new solutions to meet the evolving needs of our customers. We are dedicated to advancing science through R&D investments and staying ahead of innovation. We take pride in our mission. At our core, we are scientists, and our purpose is to enable our customers to make the world healthier, cleaner, and safer. And supporting the clean energy market segment is a priority for us in achieving our mission. Our broad range of technologies provide solutions across the battery development, quality control, and manufacturing pipeline. We execute innovation in 6 continents with a deep portfolio and infrastructure that makes us the leader in serving science and supporting our customers' operations. Thermo Fisher's capabilities for serving the battery value chain stretch from lab to line. We deliver advanced technologies enabling customers to develop new materials for the next generation of batteries, characterize and control production materials, control the production process through advanced metrology, assure battery production, formation, and assembly, inspect and release assembled cells, investigate failures, inspect and recycle or reuse cells. Our analytical characterization solutions serve the needs of the battery industry in R&D, quality control, process control, and failure analysis areas. Micro-CT is the key tool for non-destructive analysis to check the defects in the cell production environment. Aviso software provides visualization and quantification on the CT data. Electron microscopes, including SEM and dual beam, provide essential imaging capability for quality checks on the raw materials and failure analysis during electrode or cell production. Raman and FTIR are powerful techniques to study chemical and conformational changes, providing important insights for battery material quality control and failure analysis. Finally, ICP OES is the key QC step for impurity analysis during the battery production process. Our inline process metrology and control capabilities enable battery manufacturers to accelerate production, improve product quality and safety, make process decisions faster, and protect their brands. Our inline metrology systems monitor and help control the uniformity of electrode coating, thickness of calendared layers, and consistency of extrusion and coating of separator films. We support our customers' smart manufacturing initiatives with our cloud-based instrument performance monitoring technology. We also continue to innovate. Last year, we launched the Thermo Scientific Linspector measurement and control system, an inline metrology platform designed specifically for the battery industry, and this year, we have more exciting innovations to come. Thank you. To learn more, find us at thermofisher.com/battery.
I'm Lindsay Gore, co-founder and CEO of Core Power. Core Power is a US-based cell battery technology company. We have customers all over the world in energy storage, EV charging, and e-mobility. And Core Power provides the backbone for decarbonization. And cells are really the key for reaching widespread electrification. We're building a state-of-the-art 12 gigawatt-hour battery cell factory in Arizona. We believe that we are a catalyst to a green earth. So we are building a carbon neutral with solar and storage cogeneration, the first of its kind in our industry. And I hope others will follow. If you are a green company, you should do everything in your power to manufacture in that way. Supply chain. Supply chain challenges that we are facing in our industry are real and like people in other industries. If we don't have a concerted effort to alleviate this, it will not get better. I sit on the Department of Energy Battery Roundtable, and I sit on the Advanced Battery Roundtable with Select USA. And I've outlined what I think is a very solid way to take care of our supply chain issues that pertain to lithium-ion cells. We first need to identify the future requirements from an upstream to midstream perspective. And what I mean by that is from mineral to cell, right? You need a concerted effort to achieve this. Let me explain. Nothing that goes into a lithium battery is rare. That's false. I believe there's enough minerals in North America to supply our future needs for fast-growing industry. But you need to focus on both the permitting and the funding of these deposits. But once you've done that, it's not over. You have to then build the next midstream supply chain. From lithium mineral, it goes into either a lithium carbonate or a lithium hydroxide. From there, it goes into lithium salt, that goes into an electrolyte, that then finally goes into a cell. So you have to focus both on the upstream, which is the mineral, the midstream, which is the chemical, and then the actual electrolyte itself. So let's jump into the next issue we have, is employment, right? The first phase of the Coreplex will be a 6 gigawatt hour that will be in production in 2024. We need 1,300 employees for that, approximately. In 25, we need 3,000 employees. We found that we take an alternative route to creating our own recruiting pipeline. It is anticipated that the manufacturing industry will need 2.1 million unfilled jobs by 2030. That's 2.1 million unfilled jobs for manufacturing. To ensure we have the workforce required for the Corplex, we're using the power of partnerships. We have found that working with local workforce partners, we're able to gain their experience and knowledge to unlock pools of ready talent. We've identified career and technical training opportunities through nearby colleges and universities to begin training programs to fill our workforce needs. In order to establish a manufacturing base here in the United States, we need to continue to think globally, but act locally. We are working towards a global goal of diminishing the effects of global climate change, and many of us have dedicated our careers towards this mission. We need to continue strengthening the U.S. supply chain and growing the support, including government, to finance new manufacturing facilities and all the upstream associated with it. This is critical because of the massive scale required to live up to a clean electrified future. While our plant will be a meaningful addition to the industry, it is not enough. We need more partners, more suppliers, and even more competitors. This investment can happen across the entire nation. Thank you.
Hello, my name is Stefan Bergold, and I'm the head of sales at Farasis Energy USA Incorporated. We are located in Hayward, next to San Francisco in California. We are planning to build a battery factory in the United States, and by this video, we want to ask for your support. Within the next 90 seconds, I want to introduce my company to you, and I also want to introduce the project. Farasis is a global leader in the development and manufacturing of high-power lithium-ion batteries. We are focusing on the research and on the development of the cell chemistry, as well as on the mass production of the related cells, modules, and packs. Farasis is one of the two largest companies in the world to produce lithium-ion pouch cells in high volumes. As of today, we have 4,500 employees. As of today, we have an installed production capacity of 21 gigawatt hours and a clear path to extend this production capacity to 150 gigawatt hours within the next years. Our batteries are used in passenger cars, as well as trucks, buses, helicopters, motorcycles, industrial machineries, or other vehicles. We have a strong R&D network with most of the American research and development institutes and also foreign institutes, including the Department of Energy and also including the US ABC. Under the guidance of the US ABC, we are running two development projects, one to develop new cell technology and the other to develop new recycling approaches. We have multiple customers worldwide. Our most important customer is the Mercedes-Benz AG. With Mercedes-Benz, we have a strategic partnership which includes, number one, the supply of the batteries, number two, the CO2 neutral production of the batteries according to the customer demand, and number three, the participation of Mercedes as one of our shareholders and the nomination of Markus Schäfer in our board of in our advisory board. We have a global production network in Asia and in Europe, and we also want to expand to the United States. In these projects, we plan to bring our existing production technology and know-how to the United States market. We want to help to establish a domestic lithium-ion battery supply chain. We want to reduce our dependency on foreign countries, and we want to grow the battery business within the United States. We are pleased to see DOE's leadership to create a domestic lithium-ion battery industry, which has successfully been done in other regions of the world just before. Thank you for the opportunity to speak, and we look forward to work under your leadership. Bye-bye.